Good afternoon, sir. Good afternoon. Good afternoon, everyone.
Good afternoon, sir.
Good afternoon,
Yes,
sir.
sir.
Yes,
Good
good
afternoon.
afternoon.
Good afternoon.
Good afternoon, sir.
Sir, myself, Professor Jana, head of the Department of Electrical Engineering, would like to welcome our eminent speaker, Dr. Debangshu De, to begin with this particular session of the second day and the final day of the program. And definitely the kind of input which will be really shared by him will be definitely beneficial to the students community as well as the faculty community. Sir, over to you, sir. Okay.
Thank you, sir, Professor Dr. Jana. Now, before we proceed with Dr. Devanshu De's lecture, I would like to introduce sir to all the participants present here on Google Meet as well as the students who are viewing us live on YouTube. Professor Dr. Devanshu De received his BEE, MEP, and PhD degrees from Jadavpur University, Kolkata in 2003, 2005, and 2009, respectively. Presently, he is working as an assistant professor in the Department of Electrical Engineering, Jadavpur University. Dr. De has published more than 50 international journal papers in the fields of his research, including 20 papers in IEEE transactions, and he has co-authored one book from Springer Verlag, London, and also two edited volumes published by IEEE. Four patents have been granted to him, of which one is a US patent. He is a recipient of IEI Young Engineer Award in 2014, TARE Research Associateship from SCRB Government of India in 2018, Vishwacharya Young Faculty Research Fellowship in 2019, Outstanding Chapter Engineer Award by IEEE PES Kolkata, and two Best Paper Awards. He was a visiting researcher at ISI Kolkata and visiting faculty member at the University of Applied Sciences, Augsburg, Germany. His areas of interest are applications of signal and image processing tools in electrical and biomedical systems, condition monitoring of electrical equipment, non invasive testing related to condition assessment. Presently, Dr. De is in charge of Measurements and Instrumentation Lab, Jadavpur University, Secretary of IEEE Kolkata Section, and Chairman of IEEE Signal Processing Society, Kolkata. Thank you. Now, I request Dr. Devanshu De to continue with his illuminating lecture. Sir,
Thank you. Thank you for this nice introduction. And I'd like to thank the organizers, especially the Bajbaj Institute of Technology, Electrical Engineering Department, for giving me this opportunity and organizing this program. So it is a very nice opportunity for me also to interact with all of you. And before I start the presentation, can I share my screen now?
yes, sir. I have stopped presenting. Now you can share your screen.
Yes, okay. Thank you. Is it visible now?
Yes, sir. Yes, sir. It is visible.
Okay, thank you.
Sir, may I
Uh,
request one small thing that hide
yes.
is written, so you may click there because that will
No, no.
cover.
Yes, yes. Okay, I'll just shift it.
Okay, sir. Okay. Yes, sir. Thank you, sir. Thank you.
Then, okay. So, is it okay now?
Yes, sir. It's perfectly
Yes,
fine,
sir.
sir. Fine, sir.
Okay. So, thank you. So, again, very good afternoon to all of you. Today's topic for this particular lecture is the recent trends in the condition monitoring of power transformers. And we actually interested in transformer because of the fact that it is a very costly equipment in terms of the all the assets that one can have in a power station. uh, Course idea is that if you add up all the cost of a power station, then approximately half of the cost will be bear by this that will be of the cost of the transformers. So transformers are very important assets. So that is why the condition monitoring of transformer is very important. And if I look into the functional part of the condition monitoring, not only for transformer but for any other electrical equipment, we can see that it can be divided into two parts, two functional parts. First of all, we have to acquire some data. That means, say we are trying to understand the condition of a transformer, then we have to perform some experimentation and we have to get data. So data acquisition is one part, and after having the data, we have to analyze the data. We have to analysis that part, and we have to make some decision. We have to have some rule base or some intelligent system or some decision making system, so that we can have an idea about the condition on the basis of the data that we have acquired. So these two parts are the basic functionality of any condition monitoring task. Now, for transformer, especially for the power transformer, if we look into the power scenario of India, of our country, that if we just think about the designed life of a transformer, it can be, say, 30-40 years. Okay, so whenever the transformer is designed, it is designed to at least serve for the 30-40 years. Now, this 2010, 2000, in this time, most of our installed old transformers, they have come to the end of their design life. That means during, if you think about 70s, then approximately all of the transformers are now very vulnerable, as well as they are very costly. So overnight we cannot change them. So now the important part is that we have to understand that which transformers are very critical. That means the condition of the insulation, condition of the overall performance, that are not very good. So we have to replace them, and we have to plan for it early. Why we have to plan for it early? Because I told you that transformers are costly. So even for a large transformers or a few hundred MVA, that may cost more than crores. So there is no such transformers. Transformer manufacturers, they are ready with the required transformers. So once you require some transformer, you have to order it, then they will say make it. So therefore, you have to know the condition of the transformers, and then you can place your order, or you can plan your procurement of the transformers. So that is why the condition monitoring nowadays are very important aspect of asset management of any power utility. So if we look into the first part, that is the first functional part, that means the data acquisition. That means what are the different data we can acquire. And there are some classical things. As the topic of the lecture is the recent trends, I will just bypass all the classical old traditional methods, but do not underestimate them. They are quite very efficient as well. So nowadays, apart from those classical methods, some new methods have come up. So we will be discussing more about them. So data acquisition, if we just discuss, one of the important aspect of condition monitoring of the transformer is the impulse test. That means we have to apply some impulse, say a surge or say a switching impulse. That means a very high voltage. It is rise time is very short and it falls very quickly. So a sort of, as you know from the term impulse, the sort of an impulse signal we can apply to the transformer. And in practical life, if lightning strikes or if sudden switching occurs, this kind of a impulse signal can be generated, and transformer should withstand that. Otherwise, it may fail. So therefore, their fault will occur. So the system will become, no, out of the operation. So therefore, the system, the revenue loss may occur. So that is why before installing a transformer to a system, we must apply some impulse voltage, and you have to check what are the responses and whether the transformer insulation is quite capable of withstanding that impulse, this kind of impulse. We have to check that. This is a very block diagram representation of that kind of testing. And usually here, the very high voltage we cannot acquire. For data acquisition, you know that if your impulse voltage is say 75 kV, that 75 kV, the CRO and other let's say data acquisition systems, they cannot directly measure the 75 kV. So you have to divide it. So you have to reduce it by using a potential divider. There are different types of potential divider. Resistive dividers are not usually used. The capacitive potential dividers are used because they are very energy efficient. Okay, because you know that the energy loss in resistors due to flow of current is high, whereas for the capacitors they are not that much. So usually we prefer the capacitive dividers. So one aspect is that, so we can take the data of an impulse testing. That means we can apply some impulse voltage and we can record some data. That is one aspect. The second one, that is the most recent one, that is the very recent one, and this is called the polarization depolarization current measurement. And this particular measurement is very useful, and we should call it a non-destructive testing. Sometimes you know that, say like for a human being, the blood test, for the blood test, the purpose of blood test is that is very indicative to the any disease in your body. The same thing we can do with the transformer using the transformer oil test. Oil is like the blood of the transformer. My sir used to say this kind of analogy. I am also using this. So the blood of the transformer, that is the transformer oil, that flows to the transformer through different parts. So if you take out some oil and if you test it, then you may have some idea about the condition of the transformer. But that we should say an invasive method. That means we have to take out something from the transformer. And if your transformer is just on operation, then it is not always possible for you to take out this kind of a measurement, to carry out this kind of a measurement, to take out the oil. But now it is okay. Even if the oil you can take out, there are other insulating materials. You know that there are paper, press board, etc. And also nowadays for the dry type transformer, the resin cast transformer, the solid insulations are there. And solid insulation, if you are trying to take it out, then that will damage the transformer. So that is a definitely invasive method. So that is not allowed usually. So PDC, this polarization, depolarization current measurement, that is very new one and very effective in the sense that it is not an invasive one. Invasive one means that is you don't have to just take some portion out of the transformer and going into the transformer say assembly, and you have to take out something. From outside you can give some signal. From outside you can record some response, and you can analyze the record, and you can get some information about the transformer. And here, this is the basic structure of polarization depolarization current measurement. I am just showing this circuit diagram because of the fact I am discussing about the data acquisition part now. So you can see very interesting thing is that this is a very simple, the figure number A, that is a very simple structure, low voltage and high voltage windings, their insulations are different level. Now, if we short the two terminals, you know that one winding has two terminals, one start and one finish. So if we have one low voltage and one high voltage, both of them will have two terminals, so total four terminals. Now, if we short the low voltage winding, so that is one electrode, and if we short the high voltage winding also, that will give us the electrode number 2. So if we apply some voltage across these two, what will happen? So now you can see the electrode 1 and electrode 2, and in between the insulation is there. So whenever we talk about the condition monitoring of transformer, we usually mean the condition of its insulation. That means how good is the insulation. If its insulation is good, then it can continue in service. If its insulation has become weaker or older, then we have to replace. Otherwise, there can be a dead short circuit within the transformer. Okay, so that is why whenever we talk about the condition monitoring, we usually talk about the condition of the insulation. So now electrode 1 and electrode 2, they are metal portion, they are the conductors, and in between the insulation of the windings as well as the oils etc. is there. So from circuit point of view, it is sort of a capacitor. Can you understand that? It is a sort of capacitor. Why? What is there inside a capacitor? Inside a capacitor, there are two electrodes, and in between the electrodes, there exists a dielectric material that is the most of the cases an insulating material. So therefore, here also electrode 1 and electrode 2, if we give supply some voltage across these two, so the overall insulation system will behave like a dielectric, and the system will act as a transformer. Is a capacitor. The transformer will behave like a capacitor. So therefore, the transformer now will behave like a capacitor. So if we give some voltage, so capacitor will be charged. That is called the polarization current. And if we after charging, if we short circuit the two electrodes, then there will be discharge of that is called the depolarization current. So basically, polarization and depolarization current is nothing but charging and discharging of the insulation of the transformer. So we have to make the circuit in such a way that it behaves like a capacitor, and then we charge it, then we discharge it, and look into the waveform. There are certain models, and from that model we can have the idea about the condition of the insulation. The other B and C diagrams, they are also same with the say ground terminals availability and three-phase transformers etc. with tertiary winding. Okay, so basically all of them will behave like a capacitor. The insulation system will behave like the dielectric, and we are going to supply some voltage across electrode 1 and electrode 2. So you know that what we'll have to do now. So once you have that voltage as well as the current, then you can model the system. Electrode and the low voltage electrode, two terminals are shorted, you can see here, and the DC source is the high voltage. Usually the voltage source is on an around of 1 to 2 kV. So 1 to 2 kV voltage will be supplied.